Hello students, so let's try to solve this particular problem. This is from quantum mechanics and particle in box. The system is basically particle in box, but we have to talk about the time evolution of probability density. So the potential is given and the wave function at t is equal to 0 is given, that is superposition of ground state and first excited state. And it is identified that after time tau, the particle will be in the equally likely in the any half of the box. So either it will in the left half of the box and the right half of the box, and that is equally likely. That means that probability will be half. So we will discuss that thing, how I am saying that thing. So we have to calculate the value of tau h upon ml square. So we have to calculate this particular value. So first we have to see what are this particular potential. So this potential is basically a symmetric potential. So this is my potential. So this potential is symmetric one. So that will be from minus L by 2 to L by 2. And the state at t is equal to 0 is given psi x0 is equal to 1 by root 2 phi 1 x plus phi 2 x. Hence, we can see this width is L, but this is symmetric about x is equal to 0. Then my phi 1 is basically root 2 upon L cos pi x upon L. And what is your phi 2? Your phi 2 is basically root 2 upon L sine 2 pi x upon L. And these two are normalized wave function. So this is first thing we have to just know before solving this problem. And what we have to do, we have to just, according to this particular problem, it is given that psi xt mod square dx and any half, so I will just take from 0 to L by 2, that value is equal to half. And this is at the time t is equal to tau. And then what we have to do, we have to calculate the value of tau. So this is your tau h upon ml square is equal to what? So we have to calculate this particular value. So first we have to go for time evolution of state. So when we will go for time evolution of state, then we have psi xt is equal to, that will be 1 by root 2 will be remain same, and this will be phi 1 e to the power minus I E1 t upon h cut plus phi 2 e to the power minus I E2 t upon h cut. And then when we will go for mod psi xt whole square, then what we will get? We will get this value as 1 by 2 mod phi 1 square plus 1 by 2 mod phi 2 square plus 2 times real part of phi 1 and phi 2, so that both are real. So 2 times we can take phi 1, phi 2, and 1 by 2 is also there. 1 by root 2 and 1 by root 2, 1 by 2 is also there. And this value is equal to, we have phase part, that is cos E2 minus E1 t upon h cut. So we have this particular mod psi t square. And then we will just go for integration. So we have to just apply this particular thing. So when we are going to apply this one, so then we have to go for mod psi xt whole square, and this dx must be equal to half. So when we are going for here, then we will go for, and this will from 0 to L by 2 according to my problem. So this will be, so this value is basically, we will go from 0 to L by 2, 1 by 2 mod phi 1 square, and this time factor will be gone, and dx is there. Another is, we have 0 to L by 2, 1 by 2 mod phi 2 square, this is also there, and we have 2 into 1 by 2 integration 0 to L by 2, and this value is equal to phi 1, phi 2 dx, and we have cos E2 minus E1 t upon h cut. So we can take it separate. So now when we will go for, and this value is equal to what? This value is equal to half. So I will just keep it out. So this value is equal to basically half. So let us write it completely. Into cos E2 minus E1 T upon h cut must be equal to half. And now we have to calculate all this thing. So when we are going to calculate this one, there is not any need to do this integration. We know this is the probability such that particle is found in the ground state between 0 to L by 2. So that will be half. So this value is 1 by 2. This integration is half. Plus again we will go for the half is coefficient, the integration, and this is dx. So integration phi 2 square dx, that will again tell you the probability to find the particle between 0 to L by 2 if it is in the first excited state. So that value is equal to again 1 by 2. And the whole idea is that this 2 and this 2 is cancelled and this number is there. So we have cos E2 minus E1 T upon h cut. And this particular integration is very interesting. 0 to L by 2, phi 1 is equal to root 2 by L, and this is your cos pi x upon L. Phi 2 is equal to root 2 by L sine 2 pi x upon L dx is equal to 1 by 2. So when we will go for this particular integration cos and sine 2 pi x, we can easily solve this integration by just opening up sine pi x by L into cos pi x by L into 2, and we can just solve this one. So this integration will be come out to 4 by 3 pi. I think this will be my integration. So let me check. So that is 4 upon 3 pi. So you can just do this integration cos pi x by L into sine 2 pi x by L dx into 2 by L is equal to 4 upon 3 pi. Easily you can do this integration. Open up sine term, take cos pi x by L is equal to t, and then sine pi x by L dx is equal to dt. So you can easily solve this particular thing. So when we will go for this, so this value is 1 by 4, this value is 1 by 4, and this value is equal to cos E2 minus E1 T upon h cut into, and this value is equal to 4 upon 3 pi. So, and that value is equal to, and this value is equal to basically half. So what will happen? This number and this number is cancelled out, and E2 minus E1 is equal to, we can easily get cos of E2 minus E1 is equal to, this is 4 pi square h cut square upon 2 ml square. This is 1. So this is 3 pi square h cut square upon 2 ml square, and we have 1 upon h cut is also there. This h cut is also there into 4 upon 3 pi is equal to 0. And if you are not able to do this integration, then this is also not useful into the calculation, because this term and this term is cancelled out. This problem is given so beautifully. So what we have this particular thing. So we have 3 pi square h upon 2 ml square. This h cut and this h cut is cancelled. That must be equal to basically pi by 2. And time is also there. So time is also there. So this is your time, and this time is tau. So that will be is equal to pi by 2. And what we have to do? We have to calculate the value of basically. So from here we can write this h cut as h upon 2 pi. So this is 3 pi square. This is h 2 into 2m into 2 pi tau upon L square is equal to pi by 2. So 1 pi will cancel. This pi will cancel, and we have to calculate tau h upon ml square. So that value is equal to, so 1 2 is cancelled. So there is, this value is Just a minute. 2 pi, sorry, 2 into, so this 2 is not there. So this 2 is not there. So this is your 2m. So this pi is cancelled. This 2 is cancelled. So pi h ml square is equal to, when we will go into this side, this value is equal to 2 by 3. So your answer is equal to nothing but 2 by 3. So you can easily solve this thing. So actually, what is the real thing? Real thing is that how you are going to open up this integration and how you can write this integration to 1 by 2. There is not any need to do the integration. Without using integration, we can easily solve it. And even there is not any need to do this integration, because this term and this term is cancel out. And yes, you have to be very much careful, because they are asking that value of tau h upon ml square. So what is the trick? You have to write h cut upon h upon 2 pi. So everything is there, and this value is 2 by 3. So this is your answer. Thank you.